Hello, everyone, especially to my instructor, none other than Mr. Christian Iskandantol. Hello, sir. Have a nice day. Such an honor to greet you for today. By the way, I am Maria Lorena Mendez, one of the students of Baja Island State University, Kandahar campus. And I'm a third-year student and currently taking up the course of Bachelor of Science in Environmental Science. Today, I am going to present a data and analysis with performing calculations using MS Excel. We are having three evaluations. Our first evaluation is about how to measure obligation in terms of minimum, maximum, quantiles, and by performing calculations using MS Excel. In our second evaluation is about how to measure central tendency and utilize MS Excel to automate calculation of parameters. In our last evaluation is about how to measure of dispersion in terms of range, interquartile range, variance, standard deviation, and sub-measures of dispersion using MS Excel. So are you ready, guys? Now let's begin. Here we go, our first evaluation. But before I proceed, I would like to tell you first that in this evaluation, we may learn how to state a comparison and contrast on the different measures of location. We may learn also how to solve for the minimum, maximum, decile, percentile, quartile, and to learn how to calculate all of this by using MS Excel function. Now, I will read our first evaluation. Baguio City, the summer capital of the Philippines, is known for its cold temperature all year round. The following data are the average temperature per month in 2019, which is expressed in degrees Celsius. As we see in the given data, the month of January has a 17.7 average temperature. In the month of February has a 18.4 average temperature. In month of March has a 19.4 average temperature, and so on and so forth. So here our first question. What particular month experienced the highest and lowest average temperatures respectively? The problem is looking for the months having experienced the highest and lowest average temperature. Going back in the table, by staring on it, we could identify the months having experienced the highest and lowest average temperature. But since this presentation is about MS Excel, so we are going to find this by using MS Excel functions. In doing this, we are going to use the Excel functions at maximum and minimum. The contrast both of them is when we say maximum from the word max means the largest or the highest value from the data set. And with the Excel function equals max open parenthesis range then close parenthesis. While when we say minimum from the word mean means the smallest or the lowest value in the data set. And with the Excel function equals mean open parenthesis range then close parenthesis. Note the word range inside the parenthesis requires you to highlight all the cells that contain the data set. Like for example, if you're using the column A, then in a row from number 1 and to 10, so the range that you're going to include is A1 is to A10. Another example, if you're using column E, then in a row from number 2 until 20, so the range that you're going to include is E2 is to E20. Always remember that we should be mindful in including the range. Look at the column in the row where you include your data set, and that will be your range. Since we know already the contrast between minimum and maximum with its Excel functions, now come with me and let's solve our evaluation 1. Observe the column and row that I used. I'm using the column D, then in a row from number 2 until 13. So the range that I'm going to use is D2 is to D13. So our Excel function of minimum is equals mean open parenthesis D2 is to D13 then close parenthesis. Okay, I will show you how to use this Excel function in getting the minimum value. We will assume that we don't know yet the result. Okay, this one. Let's assume that we don't know yet. These are the highlighted cells. And then we'll put equals, mean, open parenthesis. Our range is D2 is to D13, then close parenthesis, then press enter. So the result is 17.7. Therefore, by using the Excel function of getting the minimum equals mean open parenthesis, D2 is to D13, then close parenthesis, the result is 17.7. So the month has been experienced the lowest average temperature is the month of January, with the average temperature of 17.7 degrees Celsius. Now let's get the value of maximum, which represents as the highest average temperature in our problem. In getting the maximum value, just type equals max open parenthesis range then close parenthesis. Since our range in this data is D2 is to D13, so our function that we are going to use is equals max open parenthesis D2 is to D13 then close parenthesis. Then press enter. As we'll see, the maximum is 20.5. I will show you the actual computation. Okay, let's assume that we don't know yet the result. Now, let's include equals max open parenthesis and our range is D2 is to D13, then close parenthesis, then press enter. So the result is 20.5. Therefore, by using the Excel function of getting the maximum equals max open parenthesis D2 is to D13, then close parenthesis. The result is 20.5. So the month has been experienced the highest average temperature is the month of May, with the average temperature of 20.5 degrees Celsius. Now let's proceed to our second question in our evaluation 1. I will read our second question. Find the second quartile on the data set. What does the value imply? The second problem in our evaluation 1 is looking for the value of second quartile and also the value implied on it. To make it clear and to have a better understanding regarding this, I will give you a short discussion about these quintiles. Quintiles are measures that give the position of the data value relative to the entire data set. The three types of quintiles are percentile, decile, and quartile. When we say percentile, it measures the position of single data item based on the percentage of data items below or equal to that single data item. It divides data set into 100 equal parts. In getting the percentile, just use the Excel function equals percentile, open parenthesis, array, comma, k, then close parenthesis. When we say decile, are the 9 values denoted by D1, D2, and D9 along the scale that divide the dataset into 10 approximately equal parts, 10%, 20%, and so on and so forth. In getting the decile, just use the Excel function equals percentile, open parenthesis, array, comma, k, then close parenthesis. When we say quartile, these are the 3 values Q1, Q2, Q3 that divide the dataset into 4 approximately equal parts, 25% as the Q1, 50% as the Q2, and 75% as the Q3. In getting quartile, use the Excel function equals percentile, open parenthesis, array, comma, k, then close parenthesis. Note, array also means to highlight the cells. containing the dataset. As you notice, array and range are both comparisons in getting the value of it. If you still remember, I told earlier about the range. For example, if we're using the column A, then in a row from number 1 and to 10, so the range is A1 is to A10. And that will be also your array. Another example, if you're using the column E, then in a row from number 2 and to 20, so the range is E2 is to E20. And that will be also your array. So now, let's proceed of how to get the value of letter K. I will show you some computations in getting the value of letter K. So just read on and post the video. Observe the Excel functions of the three types of quantiles. Their comparisons, as we notice, that the Excel function for decile and quartiles are the same as the percentile. So from the definition of these parameters and their comparisons, we can say that our first decile is equal to 10 percentile. The T2 is to P20. P3 is to equals to P30, and so on and so forth. And please take note that our 50 decile is equal to 50th percentile or P50 is also our second quartile or Q2. Our Q1 is also our P25. Our Q3 is also our P75. I hope from my short discussion, you will understand and we can answer the second question. Now, let's start answering. Since our second question from the evaluation 1 is looking for the second quartile on the data set, as we learned earlier, that the second quartile will be our 50 cell and also our 50th percentile. Then the key value of 50th percentile is 0.50, coming from 50 divided by 100. So our Excel function that we are going to use in getting the value of second quartile is equals percentile, open parentheses, D2 is to D13, comma, 0.50, then close parentheses. From this data, the highlighted cells containing the data was in column D, in row 2 until 13. So the array is D2 is to D13. I'm getting the P50 because the value of second quartile will also be 50th percentile. So by dividing 50 into 100, the quotient is 0.50 or 0.5, which is the value of letter K. Or we may also use equals quartile, open parenthesis, D2 is to D13, comma, 2, then close parenthesis. They both the same result. So our Excel function is equal percentile, open parenthesis, D2 is to D13, comma, 0.50, then close parenthesis. Or we can use equals quartile, open parenthesis, D2 is to D13, comma, 2, then close parenthesis. I will show you the actual computation. Okay, let's assume that we don't know yet. Okay, we will include the equals, percentile, open parenthesis, and our range is D2 is to D13, comma, 0.50, then close parenthesis, then press enter. So the result is 19.35. Thus, our second quartile or Q2 in the data set is 19.35. This value will also imply is our 50th percentile or P50 and also our 50 cell or T5 in the given data set. For the summary of our evaluation 1, the month of January has the lowest average temperature with 17.7 degrees Celsius. The month of May has the highest average temperature with 20.5 degrees Celsius. And our second quartile is 19.35 degrees Celsius, which also implies is our 50, P50, and T5. Now let's proceed to our second evaluation. Okay, we're done in our first evaluation. Let us proceed to our second evaluation. In this evaluation, we will learn how to compare and contrast statements on the measures of central tendency. We will learn also how to solve mean, median, and mode by utilizing MS Excel to automate calculation of parameters. In addition, the measures of central tendency are the values where a set of observations tend to cluster. These are also called averages. There are three most commonly used averages: mean, median, and mode. I will read our second evaluation. Suppose that the data below represents the pH level of 10 major lakes in the Philippines. As we see in the table, Laguna de Bay has a 4.63 pH level, Lake Lanao has a 4.48 pH level, and Taal Lake has a 4.96 pH level, and so on and so forth. Now, let's turn the page to the first question of Evaluation 2. The first question is, what is the average pH level of the major lakes in the Philippines? To solve this problem, we need to learn and recognize the function of mean in this problem. Let's have a short discussion of mean. Mean is the sum of all observations in the dataset divided by the total number of observations, which means in manual computations, we are going to add all the given numbers, then divide its quantity. Like for example, back to our table. We're going to add all of the pH level, then divide it into 10 because the pH level has 10 quantities, and the result is what we called mean. Take note that there is only one mean in a given data set, and it's defined only for quantitative data, and the presence of extreme values affects the mean. Its Excel function is equals average, open parenthesis, range, then close parenthesis. Now, we will solve the problem through MS Excel. In Excel computation, since the problem is looking for the average, then we will use the Excel function of mean, which is equals average, open parenthesis, range, then close parenthesis. As you see from the table, the highlighted cells are in column E and in a row of 2 until 11. So our range is E2 is to E11. Now I will show you how to compute the mean by using Excel computation. Let us assume that we don't know yet the result. Okay, let's assume that we don't know yet. These are the highlighted cells and that this will be also our range. Okay, well, it could equals average, open parenthesis, our range is E2 is to E11, in close parenthesis, then press enter. So the result is 5.268. Therefore, the average pH level of the major lakes in the Philippines is 5.268 by using the Excel function equals average, open parenthesis, E2 is to E11, then close parenthesis in getting the average of the said data set. Now let's proceed to our second problem from the evaluation 2. Our second problem from the evaluation 2 is find the middle value of the data set. In this problem, we are going to learn the function of median. Median is the middle value when data are arranged in increasing or decreasing values. In a simple word, it is the middle number of the given numbers. But take note that there is only 1 million for a data set. That's why, if ever it contains 2 million numbers, simply add then divided it by 2. Then the answer will be the median. Median is not open for advanced computation, and it's not affected by extreme values because you're just only getting the middle number. Now let's proceed to our Excel for our computation. In getting the million or the middle number of the data set by using Excel computation, we use the Excel function of million, which is equals million open parenthesis range then close parenthesis. Have you noticed the range here is not the same from the range on the first problem? It's because the highlighted cells here are in column C and in a row 2 until 11. So the range is C2 is to C11. Now I will show you the actual computation. Okay, let's assume that we don't know yet the result. So all we have to do is to type the equals million open parenthesis. Our range is C2 is to C11, then close parenthesis, then press enter. So the result is 5.05. Now let's proceed to our third question from our evaluation 2. Our third question in our evaluation 2 is there a recorded pH level that has the same with other lakes on the list? What do you call this bias with reference to the entire data set? In this problem, we need to learn the function and recognize the value of mode. Mode is the bias in the dataset occurs more frequently. Nagpasabot, nakadagan nitong ha or nakita nimo. Mode may or may exist in a dataset. Nga naman, tungod kay na ay dataset nga walay mode or walay kapareho. Then usahay pod naa or naay kapareho. There can be more than one mode in a dataset. Usahay daghan ng mode, either 2, 3, 4, and so on. It is applicable for both quantitative and qualitative data. Ang kanindot sa mode kay pwede siya sa numbers or sa qualities. The Excel function in getting the mode in a data set is equals mode open parenthesis range then close parenthesis. Now let's use the Excel for our computation in mode. In getting the mode of the given data set, we will use the Excel function of mode equals mode open parenthesis range then close parenthesis. Since our highlighted cells are in column C and in a row of 2 until 11, thus our Excel function is equals mode open parenthesis C2 is to C11 then close parenthesis. Then press enter. The result is 4.63. I will show you the actual computation. Okay, let's assume that we don't know yet. Okay, so these are the highlighted cells and that will be our range. Just include equals, mode, open parenthesis. Our range is C2 is to C11, then close parenthesis, then press enter. So the result is 4.63. This means that the mode exists in this data set because 4.63 repeated it 2 times in the data set. Since no any number repeated in the data set except 4.63, which is also the most occurred, thus the mode in the data set is 4.63. Therefore, based on the entire data set, yes, there are 2 lakes on the list that are recorded the same pH level, namely Laguna de Bay and Lake Puluan. They both the same pH level of 4.63, which these values are called mode because it occurs more frequently in the given dataset. For our evaluation 2 summary, the average pH level of the major lakes in the Philippines or the mean of the dataset is 5.268. The middle value of the dataset or the median is 5.05. And the pH level of Laguna de Bay and Lake Puluan have the same pH level on the list, and these values are what we called mode. Now let's proceed to our third evaluation. In our evaluation 3 is about a measure of dispersion or variability. It is quantity that describes the spread or variability of the observation in a given dataset. A higher value indicates a greater variability of a dataset. Some common measures of dispersion include range, interquartile range, variance, and standard deviation. And in this evaluation, we may learn how to solve them by using MS Excel. Here is our first question in our evaluation 3. BSMB students experimented on feeding abelins or sea snails with gracilaria for group A and sargassum for group B. Since 10 samples were measured at the end of the time frame, the data on the left are the length of abelins in centimeter after 90 days of experimentation. Here is our data given. These are the length of abelins in centimeter feeding with gracilaria in first column and sargassum in the second column. The problem is compare the two groups by solving for range, IQR, variance, and SD for each group. To answer this problem, we'll perform the calculations through MS Excel, then we will compare the two groups. First, we'll get the range of the two groups. Range is simply the difference between the highest and the lowest value. It is quickest and easiest to understand the measure of variability. One limitation of the range is that it is a fairly poor summary of spread. Therefore, it is usually reported together with a median. The Excel function of range is equals max open parenthesis range close parenthesis minus mean open parenthesis range then close parenthesis. So let's use this formula in MS Excel. In this given data, we are going to get the range value by using the Excel range formula equals max open parenthesis range then close parenthesis minus mean open parenthesis range then close parenthesis. Add the two groups gracilaria and sargassum. Since the range of gracilaria is B3 is to B12, so our function is equals max open parenthesis, B3 is to B12, then close parenthesis, minus mean, open parenthesis, B3 is to B12, then close parenthesis. I will show you the actual computation. So here, let's assume that we don't know yet. All right. Let's put equals max, open parenthesis. Our range is B3 is to B12, then close parenthesis, minus type mean, open parenthesis, B3 is to B12, then close parenthesis and press enter. So the result is 10.5. Since the group B or sargassum, the highlighted cells are in column B, then in a row of 15 until 24. So our Excel function is equals max, open parenthesis, B15 is to B24, close parenthesis, minus mean, open parenthesis, B15 is to B24, then close parenthesis. I will show you the actual computation. So for example, we don't know yet the result. So these are the highlighted cells. So we're going to include the equals, max, open parenthesis. Our range is B15 is to B24, then close parenthesis, minus, and then type mean, open parenthesis. B15 is to B24, then close parenthesis, then press enter. So the result is 10. Thus, the range of abalone length is 10.5 centimeter in feeding gracilaria is greater than the range of abalone's length, which is 10 centimeter in feeding sargassum. Now let's solve our IQR. Now let's recognize the RQR of interquartile range to solve IQR. Interquartile range, or simply IQR, is the difference between the third quartile and the first quartile. This measures the spread of the middle 50% of a data set. The IQR is not affected by the presence of extreme bias. The IQR formula is Q3 minus Q1. When we use the Excel function 1 is equals percentile, open parenthesis, array, comma, 0.75, close parenthesis, minus percentile, open parenthesis, array, comma, 0.25, close parenthesis, or the Excel function 2 is equals quartile, open parenthesis, array, 3 open parenthesis minus quartile open parenthesis array comma 1 close parenthesis. Both functions have the same result. Now let's go to the Excel for our solving. The highlighted cells of Gracilaria are in column B and in a row of 3 until 12. So our IQR formula is equals quartile open parenthesis B3 is to B12 comma 3 close parenthesis minus quartile, open parenthesis, P3 minus P12, comma 1, close parenthesis. Then the result is 4. I will show you the actual computation. So let's assume that we don't know yet. So all we have to do is to encode equals quartile, open parenthesis. Our range is B3 is to B12, comma 3, then close parenthesis, then minus, then encode again the quartile, open parenthesis. Our range is B3 is to B12, comma, then 1, then close parenthesis, then press enter. So the result is 4. So in Sargassum, I will try to use the Excel function 1 since the two functions result the same. Our Excel IQR formula in the script B is equal percentile, open parenthesis, B15 is to B24, comma 0.75, close parenthesis, minus percentile, open parenthesis, B15 is to B24, comma 0.25, then close parenthesis. Then the result is 4. I will show you the actual computation. So let's assume that we don't know yet. Okay, let's proceed to encode the equals percentile, open parenthesis, our range is B15 is to B24, comma 0.75, then close parenthesis, then minus, then percentile, open parenthesis, B15 is to B24, comma, then 0.25, then close parenthesis, then press enter. So the result is 4. Based on the data shown above, the interquartile range or the IQR of the two groups have the same value, which is 4 centimeter. Now let us proceed in solving variance. Variance is the average of the squares of the distance of each value from the mean. This is one of the most useful measures of variability. All values in the data set contribute to the computation of the variance. It is always non-negative. The Excel function is equals var open parenthesis range then close parenthesis. Now let's solve the variance of the given data set by using MS Excel. In Gracilaria, the highlighted cells of Gracilaria are in column B and in a row of 3 to 12. Thus, our variance formula is equals var open parenthesis B3 is to B12 then close parenthesis. Then the result is 10.43333. I will show you the actual computation. Right here, let's assume we don't know yet. Just include equals, bar, open parenthesis. Our range is B3 is to B12 and close parenthesis and press enter. So the result is 10.43333. In sarcasm group, the highlighted cells are in column B and in a row of 15 to 24. Thus, our variance formula is equals bar open parenthesis B3 is to B12 and close parenthesis. Then the result is 9.002778. I will show you the actual computation. So we don't know yet. These are the highlighted cells here. Now let's encode equals var open parenthesis. Our range is B15 is to B24, then close parenthesis, and press enter. So the result is 9.002778. Based from the data sets above, the variance of the gracilaria for group A is 10.43333 centimeter, which is greater than the variance result of the sarcasm for group B, which is in 9.002778 centimeter. Now finally, let's find out the value of standard deviation in this given data. Standard deviation is the average of the distance of each value from the mean. It is usually computed as the positive square root of the variance. Standard deviation, or simply ST, has the same unit of measures as that of the data set. It is usually reported with the mean. In standard deviation or ST formula, we may use function 1, which is equals ST open parenthesis range, then close parenthesis, or function 2, which is equals SQRT, open parenthesis bar, open parenthesis range, close parenthesis, then close parenthesis. Both are the same results. Note, both variance and standard deviation are used to compare two or more datasets to determine which is more or most dispersed. It is also determines the consistency of the variable of data values. Lesser variance and ST value mean less variable or less dispersed dataset. Greater value, on the other hand, means more dispersed. Now let's go to the MS Excel for our ST. In gracilaria, I prefer to use the ST formula of equals STDEV, open parenthesis range, then close parenthesis. Now, our Excel function is equal STDEV, open parenthesis, B3 is to B12, then close parenthesis. Since they were located at column B and in a row of 3 to 12, I will show you the actual computation. So let's, for in case we don't know yet, these are the highlight cells. Just encode the equals STDEV, open parenthesis, our range is B3 is to B12 and close parenthesis, then press enter. So the result is 3.230067. While in the sarcasm, I use the standard deviation formula equals SQRT, open parenthesis bar, open parenthesis range, close parenthesis, then close parenthesis. The highlighted cells are in column B and in a row of 15 out of 24, so our formula is equals SQRT, open parenthesis bar, open parenthesis, B15 is to B24, close parenthesis, then close parenthesis. I will show you the actual computation. Assume here, these are the highlighted cells that will be our range. Just include equals SQRT, open parenthesis, bar, open parenthesis. Our range is B15, is to B24, close parenthesis, then close parenthesis, then press equal. So the result is 3.0000463. Based on the results from the data above, the standard deviation of group A gracilaria is 3.230067 centimeter, which is greater than the standard deviation of group B sarcasm is 3.000460 centimeter. In evaluation 3 summary, it is obvious that the group A gracilaria has a greater variance in ST than the group B sarcasm, which is the less variable or dispersed. Therefore, the more dispersed or has more growth variability in terms of length and centimeter goes to the group A gracilaria. Now we're done in our 3 evaluations. I hope you learned from it. Thank you and see you to the next video about representing data into graphical form. Bye bye. Thank you.